Salutations, my good sirs.
What's up, my homies?
Hello, hello, BAM fam. It is Thursday, October 22nd, 2020, and here is what you missed. Taking a little bit of a closer look at scale, we find ourselves on this graphic where I have equated meters in zooming out to money. So if you've ever heard anybody say, if I had $1 for every time I'd be rich, then you understand where this motivation came from. Let's assume that human beings are a $1 value. $1 is representing 1 meter. 1 meter is 3 feet. So the average 2-year-old, 2.5 maybe year old is like 3 feet tall. Little kid. We all grow a little bit taller than that, but still a good frame of reference. So if I had $1 for every square meter that I had to zoom out in order to see the Earth's distance from the sun, I would have over $1 trillion, which would be the same amount of money as Jeff Bezos, give or take a little bit. So technically, Jeff Bezos has $1 for every meter between Earth to the sun. That's kind of crazy. But even more alarmingly is if I had $1 for every meter of the observable universe, square meter, I would have an unfathomable amount of money. But we're not really concerned with the big right now. We're talking about the very, very, very small. So let's go in reverse. If $1 was removed from my bank account, for every square meter that I had to zoom in on my microscope to see something as small as a red blood cell, I would have negative $1 million. Now, that seems like a whole lot of debt, but imagine if I had $1 removed from my bank account for every square meter I'd have to zoom in on my microscope to see a singular atom. And whew, it ain't looking so good. We reviewed the charges of the 3 particles that make up atoms, starting with a proton. Proton, y'all pretty much nailed. Proton, positive. P, P-O, proton, positive. Gets a little weird though when we talk about the electron, as the electron is negative. Let me tell you a secret about how to remember that. Electron, electrocuted. Both start with electro, and getting electrocuted is a pretty negative experience. Lastly, we have the neutron, completely absent of graphics, completely absent of emojis because it has no charge. In an argument, a neutron remains neutral. The neutron is literally the Switzerland of the atomic world. Never in a war, never trying to connect with anybody, never trying to disconnect, they just are. Now, the reason knowing the charges of the particles is important is because they are going to be attracted to and not attracted to other particles, and that's going to cause a lot of things like heat and energy and combination of atoms into molecules, all stuff that we're going to learn about a little bit later. For example, you see 2 protons in front of me. 2 protons carry a positive charge. Things that have the same charge are not attracted to each other. They repel each other. If you've ever tried to put 2 magnets together of different charges, they will repel each other, so you might have felt that. The electrons repel each other just the same because they are both negative. They are both negative. Now, what about a proton and electron? Since one is positive and one is negative, when they meet, they get together. And a lot of them stay together because opposites attract, so they say. Now you might be wondering why the neutron isn't featured in this. Well, it's because the neutron doesn't have a charge. The neutron doesn't play the game. Now we started completing an assignment today that you will find in Google Classroom under the title atom investigation, just go ahead and look for the red question mark emoji. It's the most recent assignment under our current topic of study. Looks like this. What it is a collection of mini lessons that I developed for you based on your questions about the atom. Some of these questions don't necessarily connect directly to our curriculum, but it's so important to me that you learn the things that you want to learn about what we're talking about. So, for your homework, especially if you were absent today, you'll notice as you scroll down, each mini lesson is blocked in by color. So there's a red one, there's an orange one, yellow one. I think you see where this is going. So there are 6. All you need to do is scroll through your options, which include, what do atoms really look like? How do we split/handle atoms when they're so small? Who discovered the atom and why is it called an atom? How do atoms combine to form molecules? Where do atoms come from? How are we made of atoms? 6 questions. You got to do mini lessons for 2 of them. The 7th piece down here are just questions I answered for you because they definitely didn't pertain to our curriculum, or there were just like so many questions about how to make a bomb that I thought I should just let you know that I can't legally answer those for you. You're gonna have to Google around, but I do caution you, the FBI will tap your wires if you Google how to make a bomb too many times. I don't know that from experience. Now, pick one of these. For example, we'll start here. The gray bar is going to tell you what to do. It's going to say, watch this film or watch this simulation. So all you do is you click the link to that film or simulation. It's going to open up. It's going to start playing for you after it tries to sell you something you don't need. And periodically throughout this film, you might be asked to respond to questions, or it may be so that your assignment is set up for you to watch the entire film and then respond afterwards. So let's pretend like I watched this whole movie. It was dope. Let me just pause quickly on the image of the atom. Woo! That's super cool. That's an actual image. Now, I go back to the assignment after I've watched the movie. What does it say? Oh, what are my thoughts? Then I would use this blank to say, well, maybe I'll do it like this. Well, that was interesting. It must be quite hard to take a photo of something so small. I did not win any awards for my typing skills. Then, oh, look, I'm still in my mini lesson. I'm gonna go to the next one. I'm gonna cue that up. It is gonna teach me really cool stuff about the atom. Let's say I watch it all the way through. Here's another image of an atom. Super cool. Collection of atoms, rather. I go back then to my work and I respond to this one. Sick. But y'all will say more than that. Then, oh look, I have 2 more. You get the idea. Now, are they all videos? No. Let's see. Some of these have simulations. For example, this one about how do we split atoms when they're so small. I'll click on these films. You want to watch them in order, so you watch this one. This one will tell you what a hadron collider is. This one will animate the inside of the collider. But then we come down here, after I tell you what I learned, I come down here and I'm like, ooh, it's a simulation. So I'm going to click that open, and now this is going to rely on my involvement. I see a giant U-235 nucleus. It's uranium. And I have a key over here telling me the blue are protons and the gray are neutrons. See a play button, so I'm going to play that. Oh, and here comes the neutron, and boom. I see fission is being noted, and wow. Okay, so that neutron smashed into that nucleus, and now, oh, I think that was a chain reaction. I go back to my document. Oh, what did I learn about the relationship between explosion size and atom quantity? I learned that the more atoms that are present, in the container, the larger the explosion will be. So I've completed, let's pretend, I completed the red lesson, I completed the orange lesson, and there's other lessons, but I don't have to do those because I only got to do 2 for homework. That's right, just 2. But I am going to scroll down here and read the questions that Miss Hunker answered for me because I'm curious. So, yeah, as it turns out, there are a lot of atoms in our bodies. That's actually pretty interesting. Cool. But anyways, y'all, that's your assignment. Go ahead and get that done. You crush it.